Welcome back to the channel. I'll be showing this simple, easy to make levitator today and discussing why you should always check your brand new components, because this particular red board was actually faulty from the factory. Right, let's get on with it. So here is my rather messy small work table, and this is the point really, because for about 4 days now I've been trying to make a simple magnetic levitator and I was having so many troubles. I thought I would use one of these modules to make it somewhat easier, and then discovered something. Well, if you look at this picture on the screen, you can see that the pads that are connected to are that one, and that one looks a little different. If we look on the right side image, you can see that's actually a pad of itself, and I think the idea is to be able to use different Hall sensors. Well, it so happens, take a look at this one, if we can get it to focus. That left pad has got no solder on whatsoever. That's why I believe I've been struggling to make the levitator. Where it says G near the bottom left, there's been no solder at all, and on the reverse side it's never been touched. So how about that? The message being to check your components thoroughly, otherwise you'll waste 4 days getting nowhere. Now that I know that, I'm going to resolder on the 49E Hall sensor and try again. There, the sensor has been reattached, and there it is, the very first levitation. Oh, I'm delighted with this. The very first time it's worked on the messy desk. I decided to try and use a bolt to increase the power of the system. So I found one, and it was a bit too small diameter. So I got some steel wire and wrapped that tightly around it multiple turns. And then you can see, once it was put into a similar sewing bobbin, it actually fit very well. There's been a good improvement with using the bolt down the middle, and it's enabled this 1.65 grams weight of a screw with the magnet on top to be levitated, and the other way could only do about half a gram or something like that. So it certainly improved it. And also, by changing the resistor to 150 ohms, we're now down to current usage of, here we go, 40, wow, 20, 40, about 30 milliamps. So, wow, I'm very impressed with that current usage. There we go. As you can see, it's very stable as well. This is kind of cool. If you can hear over the wind noise outside, we've got a lot of wind going on. But if you listen to the coil, it's like a woo 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 woo, like a UFO perhaps, and then the shape underneath, kind of interesting, just a bottle top. But it's making that odd sound as it adjusts itself with the Hall sensor. Next, I'll look at the components, then I'll show the circuit diagram. And the thing is, I think I'll keep it at this state at the moment as version 1, because the video will go on too long otherwise. But I'm hoping to do things like take this circuit off, put it down below, take these components off the board, make a proper board with them, and change the structure here to be more like a hangman's gallows kind of thing instead of the N shape. Right, so I'll talk about the components next. Briefly, the 5 volts USB goes into an XL6009, and that's a DC to DC boost converter. Here's one on the screen. You can see there, very cheap module but very effective for changing voltages. And I've got 2 lines. I've got 5 volts out, which is from the USB, and 12 volts out, which I've set with that pot there. The 12 volts powers the coil, the 5 volts powers the Hall effect circuit, and also the LM35A, which is underneath this pot. The pot adjusts from 0 to 5 volts, and I use it along with the blue one on here to get the levitation correct. So that's kind of just a quick overview. Next thing we'll do is look at the schematic. Here's the components diagram. I've decided to use fritzing because of the kind of components used. It's difficult to tell on a schematic. So a couple of things to note are that when there's nothing being levitated, the circuit can draw about 200 to 250 milliamps. So that resistor of 150 ohms can get hot. So I'd recommend using at least a quarter watt and larger if you've got one. That's if there's not something being levitated all the time. Also, the S8050 NPN transistor is emitter-based collector. It doesn't need a heatsink on it or a penny superglued to it, anything like that. It seems to run fine. It's good at current handling. There we are. It's a very simple design. Doesn't use a MOSFET and works really quite well. Thanks very much for watching.